Have you ever imagined a world where bizarre creatures, half cat, half crocodile, with fangs as long as cleavers, strolled under a blazing sun? No, this isn't a trailer for the next Pixar animated movie. This was Earth, over 250 million years ago. Back then, there were no roaring dinosaurs, no birds in the sky, not even grass on the ground. But don't think the planet was boring. On the contrary, it was like a theme park of evolutionary chaos, where survival meant mutating into the weirdest shapes possible. Scientists call this time the Permian period, the final chapter of the Paleozoic era, and it's one of the most critical chapters in the epic saga of life on Earth. At that point, all land masses were fused into a single supercontinent known as Pangaea. Imagine being able to walk from Brazil to China without a passport, but you'd better carry a spear and wear good running shoes, because your neighbor might be a 4-meter-long beast with shark-like teeth and a bit of a temper. As for the sea limate, brutal. At noon, you could probably fry an egg on a rock. At night, you'd freeze like a meatball left in the back of the freezer. These extreme conditions pushed evolution into overdrive, a ruthless race where only the strangest had a shot at survival. And in this series, we're bringing back the monsters history forgot, creatures with no movies, no Lego sets, but who once ruled the world. Ready? We're about to time travel to the Permian period, a world that was wild, chaotic, and even sprinkled with some dark humor. Living on a supercontinent might sound awesome. One giant landmass, endless places to explore, and no oceans to get in the way. But in reality, it came with a lot of serious challenges. Imagine Pangaea as a massive, awkward family reunion where every continent shows up, squished into one enormous room with no fans, no ventilation, and definitely no escape routes. The air is stifling, there's no fresh breeze, and someone definitely burned the casserole. The result? A dry, dusty, overheated mess that made life incredibly hard. The center of Pangaea, miles and miles from the nearest ocean, was like a giant convection oven powered by nature. There was barely any rainfall, hardly any rivers or lakes, and plant life struggled to survive in the intense heat. Daytime temperatures could soar to extremes, and the ground was often cracked and barren. At night, the same areas could get so cold that anything without thick skin or a warm burrow risked freezing. It was like flipping between a sow and a freezer every 12 hours. This intense environment forced evolution to work overtime. Animals couldn't just chill and adapt slowly, they had to innovate fast or go extinct. Some reptiles developed ultra-thick, armor-like skin, not to look cool but to avoid turning into prehistoric bacon under the scorching sun. Others evolved ways to conserve moisture, kind of like walking water bottles with legs. Picture a reptilian camel with claws and shark teeth, not exactly cuddly but very effective. Predators, meanwhile, were just as wild. Some had heads that looked like pit bulls mixed with Komodo dragons, and bodies built for chasing prey across dry, cracked earth. These weren't graceful hunters, they were scrappy, aggressive, and tough as nails. Hunting strategies ranged from ambush attacks to sheer brute force. If you were small and tasty, you had to stay alert 24/7. And what about the plants? Since there were no flowers or grasses yet, the land was filled with massive ferns, bee mosses, and early conifers. These towering green giants looked more like props from a low-budget sci-fi movie than anything you'd find in a modern garden. But they were the oxygen factories of their time, and crucial to supporting the food web. Life in Pangaea was all about survival. Finding food was hard. Finding water was harder. Not becoming someone else's food, that was a full-time job. The food chain back then wasn't a neat pyramid, it was a brutal, chaotic game of natural selection where every creature was either predator, prey, or both. To live through this era, a creature needed more than just good looks. They needed fast reflexes, a tough exterior, a flexible diet, and a bit of evolutionary luck. And maybe, just maybe, a suit of natural armor, built-in sunscreen, and a very good hiding place. Welcome to the main stage of the Permian period, a time when creatures didn't just survive, they thrived. Fiercely. In this world, you didn't need a high IQ or high-tech gear. What mattered was sharp teeth, thick skin, and the stamina to chase things down. Now, let's meet each of our main cast members, with every creature representing a weird and wild chapter in the story of evolution. If prehistoric life were turned into a blockbuster movie, Inostransevere wouldn't just have a supporting role, it would be the lead actor, the one with the dramatic, slow-motion entrance and the epic theme music playing in the background. Imagine a fearsome predator, stretching more than 3 meters from nose to tail, built like a tank but moving with the agility of a big cat. It didn't purr or growl softly, it likely made deep, thunderous vocalizations that could send shivers through the bones of any nearby prey, and the most unforgettable feature, 2 enormous saber-like canine teeth jutting from its upper jaw, sharp enough to slice through flesh and possibly even bone. These weren't just for show, they were precise tools, evolved to deliver lethal bites that could end a hunt in seconds. Inostransevere was a member of the Gorgonopsids, a group of predatory synapsids that dominated the late Permian food chain. While dinosaurs often get the spotlight, Inostransevere lived millions of years before them, during a time when nature was still experimenting with the blueprint of land-based predators. Even more fascinating, it was part of the synapsid lineage, which includes the distant ancestors of all mammals, including humans. So in a weird scientific way, this terrifying animal was a long-lost cousin of yours. Think about that the next time your cat hisses at you. Its physical build was all about survival and efficiency. Long, powerful legs gave it the ability to sprint after prey or ambush them with short bursts of speed. Its muscular frame supported a massive head, and that head held some of the most powerful jaws in its ecosystem. Those jaws could clamp down with immense force, and once its saber teeth punctured the flesh of its target, there was little chance of escape. Scientists believe Inostransevere targeted large herbivores like Scutosaurus. These were armored, slow-moving creatures, but even their tough hides couldn't save them from a well-aimed attack by this apex predator. Paleontologists studying fossilized skulls of Inostransevere have found wear patterns on the teeth that suggest it didn't just bite. It crushed, tore and dismembered with terrifying precision. But brute force wasn't the only thing Inostransevere relied on. Its brain, while not as developed as modern mammals, was relatively advanced for its time. It may have used a form of basic strategy, like hiding in rocky outcrops or among vegetation before launching a surprise attack. That's a lot of brain power for something that looks like a cross between a saber-toothed tiger and a crocodile. What makes Inostransevere even more intriguing is its place in evolutionary history. It represents a kind of in-between phase, not fully reptile, not yet mammal. Its skull had openings behind the eyes known as temporal fenestrae, which allowed for stronger jaw muscles and better biting ability, a trait shared with modern mammals. It had characteristics of both cold-blooded and warm blood, animals, making it a key transitional species in the story of life. Inostransevere lived at the very end of the Permian period, just before the largest mass extinction event in Earth's history, wiped out about 90% of marine species and 70% of land species. It was one of the last great predators of its age, a fearsome reminder of nature's power, creativity, and ability to reinvent itself again and again. So, when you think of top-tier prehistoric predators, don't just jump to T-Rex. Inostransevere walked the earth first, and it did so with teeth bared, jaws locked, and the confidence of a true Permian legend. Imagine living around 265 million years ago during the Permian period, a time when most animals were evolving sharp teeth and deadly claws just to survive. In a dusty red landscape full of tall ferns and scorched earth, a creature the size of a small car, with a strangely shaped head and weird antler-like structures sticking out of its skull like broken tree branches, slowly lumbers past. Meet Asteminosuchus, one of the strangest creatures to ever walk the earth. And surprisingly, it wasn't a predator. Asteminosuchus, its name means crowned crocodile, was a member of the Dinocephalians, a major group within the class Therapsida, ancient ancestors of mammals. This group included many species that showed a mix of reptile and mammal-like traits, and Asteminosuchus was a prime example. Measuring 4 to 5 meters long and weighing up to a ton, it was large and intimidating, at least in size. But the most striking thing about Asteminosuchus wasn't its bulk, it was its bizarre skull. Bony-out group. Rouths resembling horns jutted from various places. Its forehead, cheeks, even the back of its head. Scientists still debate what these structures were for. Some think they help males attract mates, like deer antlers today. Others believe they were for defense, or maybe just for recognition within the species. Whatever the case, you definitely wouldn't forget this face if you saw it. Biologically, Asteminosuchus was full of surprises. Its teeth weren't sharp and deadly, instead, it had wide front teeth for biting plants and flat molar-like teeth for grinding vegetation. That set it apart from most Permian animals, which were carnivores with knife-like fangs. The shape of its jaw and muscle attachments suggest it could chew more efficiently, a trait that brings it a little closer to modern mammals. Despite its massive frame, Asteminosuchus was no sprinter. Its legs stuck out from the sides of its body, more like a lizard than a mammal, making it a slow mover. That probably made it a tempting target for predators like Inostrancevia, but its size and thick skin might have offered decent protection. Think of it as a plant-eating tank, not fast, but not easy to knock over. Asteminosuchus lived in a world on the brink of transformation. The Permian was getting drier, harsher, and more competitive. Many ancient species were either evolving rapidly or heading toward extinction. Choosing to be a herbivore, rare among large land animals of that time, may have been a clever survival strategy. After all, plants don't run away, and you don't waste energy chasing your lunch. However, like most creatures of the Permian, Asteminosuchus couldn't escape the coming doom. It disappeared before the Great Permian Extinction, the biggest mass extinction in Earth's history, wiping out over 90% of marine species and 70% of land animals. Today, all that remains are fossilized bones, mostly found in parts of modern-day Russia, and our imagination, helping us piece together the life of this strange, bulky, and oddly lovable animal. In a world of killers, Asteminosuchus reminds us that you don't always need teeth and claws to survive. Sometimes being big, slow, and into salads is just fine. If there's one prehistoric creature that's been misunderstood more than almost any other, it's definitely Dimetrodon. With its triangular skull, lizard-like body, and the giant sail on its back, Dimetrodon shows up all over pop culture, movies, toys, even kids' dinosaur books, as if it were a dinosaur. But this is one of the biggest mix-ups in paleontology. Dimetrodon wasn't a dinosaur at all. In fact, it went extinct around 35 million years before the first dinosaur ever appeared. Dimetrodon lived during the early Permian period, about 295 to 272 million years ago, in regions that are now North America and parts of Europe. Back then, Earth's land masses were clumped together into the supercontinent Pangaea. The climate was hot and dry, dominated by ferns and giant horsetail plants, creating a harsh environment, but one where land animals thrived and evolved quickly. Taxonomically, Dimetrodon belonged to the synapsids, a group of vertebrates defined by a single temporal opening in the skull, a level behind the eye. This feature separated them from typical reptiles and paved the way for the evolution of mammals. So, strangely enough, Dimetrodon is more closely related to humans than to dinosaurs like T-Rex. In terms of size, Dimetrodon ranged from 1.7 to over 4 meters in length, with some species weighing several hundred kilograms. Its head was large and its jaws powerful, filled with teeth of uneven length, some tall and sharp for grabbing prey, others more blade-like for slicing flesh. This tooth differentiation was a major evolutionary step forward, allowing more efficient food processing and foreshadowing traits seen in later mammals. But, of course, the most iconic part of Dimetrodon is the sail on its back, a tall triangular structure made from elongated neural spines extending from its vertebrae, covered by a thin layer of skin. There are several scientific theories about what the sail was for. Modern 3D reconstructions suggest the sail was highly vascularized, supporting the idea that it played a role in temperature control. Regardless of its function, it certainly gave Dimetrodon a signature silhouette no predator would forget. Behaviorally, Dimetrodon was the top predator of its ecosystem. It preyed on fish, amphibians, and smaller reptiles. Its legs splayed partially to the sides, less upright than later reptiles, so it wasn't built for speed, but it didn't need to be fast. It hunted by ambush, waiting in the shade with its keen sense of smell, then launching a sudden and devastating bite. Dimetrodon fossils have been found mostly in North America, especially Texas, where you can even visit outdoor fossil parks featuring life-size models, often still wrongly labeled as dinosaurs. Sorry, Dimetrodon. And here's the kicker. Dimetrodon is considered one of the most recognizable mammal-like reptiles, bridging the evolutionary gap between cold-blooded reptiles and warm-blooded mammals. Though it didn't have fur or give live birth like modern mammals, its brain case, jaw, and skull structure all show signs of what mammals would eventually become. Dimetrodon disappeared before the end of the Permian not because it was weak, but because the world changed faster than it could adapt. Climate shifts, ecological pressures, and new competitors reshaped the land, leaving Dimetrodon as a fascinating but extinct branch on the tree of life. Still, it left a legacy. As one of the most iconic and misunderstood animals in prehistoric history, and a key milestone in our own evolutionary story. So next time someone points to a picture of Dimetrodon and calls it a dinosaur, feel free to smile and say, actually that's not a dinosaur, it's one of our ancient uncles, with sharp teeth, a sail on its back, and a pretty impressive resume. If you were accidentally thrown back to the late Permian period about 260 million years ago and somehow survived an encounter with the saber-toothed gorgonopsid or the bone-crushing bite of Inus transevia, the next creature you might run into would look oddly huggable, round, bulky, slow-moving and armored like a walking fortress. Meet Scutosaurus, one of the final giants of a vanishing age. The name Scutosaurus literally means shield lizard, and it's not hard to see why. Its entire body was covered in small bony plates called osteoderms, armor embedded under the skin. These weren't shiny like crocodile scales, but they were enough to absorb impact, deflect saber teeth, and make predators think twice before biting. It wasn't built for fighting. It was built to be a walking fortress. Scutosaurus measured about 2.5 to 3 meters long, stood as tall as a grown person's hip, and weighed between 300 and 500 kilograms. With short legs, a thick neck, and a squat, heavy skull, it wasn't designed for speed. Think of a giant turtle crossed with a buffalo, then wrapped in armor. That's Scutosaurus. It belonged to the group Periosaurs, a family of heavily built, herbivorous reptiles that thrived during the final chapter of the Permian. Interestingly, the skull shape and the structure of its dermal bones have led some paleontologists to suggest a possible evolutionary link between Periosaurs and modern-day turtles. Though the theory remains controversial, the anatomical similarities are still fascinating. Scutosaurus was a plant-eater and one of the few animals that could survive in a harsh, predator-dominated ecosystem simply by not being worth the effort to eat. Its diet likely included ferns, club mosses, roots, and soft vegetation, nothing particularly tasty to a predator, but enough to fuel a slow, armored grazer with a powerful gut. Its jaws weren't sharp, but they were strong, perfect for grinding down fibrous plant matter. Without claws, fangs, or speed, Scutosaurus chose a different survival strategy. Become immovable, inedible, and unbothered. Gorgonopsids, with their dagger-like teeth, may have tried to strike it, but unless they targeted the soft underbelly, which was hard to access, they'd likely chip a tooth on its bony back. Lifting a 500 kg armored beast off the ground, not exactly worth the calories. Scutosaurus may have lived in small herds or loose groups, giving them collective defense and warning signals against approaching threats. Its eyes were positioned on the sides of its head, giving it a wide field of view, good for spotting movement, even if its reaction time wasn't stellar. Then again, when you're basically a boulder with legs, reaction time isn't a huge priority. Sadly, Scutosaurus didn't make it past the end Permian mass extinction, the worst biological crisis in Earth's history. Global warming, volcanic activity in Siberia, ocean anoxia. The world collapsed, and even the most armored creatures couldn't protect themselves from ecosystem collapse. No amount of plating could stop the sixth inning of a planetary reset. Today, fossils of Scutosaurus have been found primarily in Russia, especially in the Kirov region, which was once part of a vast floodplain. Thanks to well-preserved skeletons, paleontologists have been able to reconstruct a vivid picture of this strange, formidable, and oddly lovable herbivore. Scutosaurus reminds us that in a chaotic world, survival isn't always about being the fastest, the fiercest, or the smartest. Sometimes the best strategy is to keep your head down, eat your greens, armor up, and mind your own business. Most people think the prehistoric world only became truly dangerous when the dinosaurs showed up. But the truth is, long before dinosaurs walked the Earth, this planet was ruled by creatures just as terrifying, perhaps even more brutal. One of those creatures was Ankylosaurus, a true heavyweight from the Middle Permian period. The name Ankylosaurus literally means opposing lizard or confrontation lizard, and honestly, it couldn't be more fitting. With a head the size of a sink, jaws like a toolbox, and teeth big enough to make you back away instantly, Ankylosaurus embodied the phrase, hit first, ask questions later. It lived around 265 million years ago, when the supercontinent Pangaea was still one giant landmass, the climate was hot and dry, and every creature was locked in a game of evolve or die. Ankylosaurus belonged to the group Dinocephalia, part of the larger class Therapsida, which includes the ancient ancestors of mammals. But don't expect any signs of cuteness or fuzz innis here. Ankylosaurus was still raw, ancient, and absolutely massive. In terms of size, it could reach up to 5-6 meters long, weigh over 500 kilograms, and had a skull up to 80 centi long, bigger than any other predator of its time. Its head was truly unique, thick-boned forehead, large snout, deep-set eyes, and bony ridges on the top and back of the skull, likely used in headbutting contests, much like modern-day musk oxen or bighorn sheep. Picture a hippo fused with a prehistoric crocodile wearing a Viking helmet. That's Ankylosaurus in a nutshell. But it wasn't just muscle and menace. Ankylosaurus had several features that hint at evolutionary progress. For example, its teeth were beginning to specialize, some long and pointed for stabbing, others flatter for crushing, which marked an early stage in the differentiation of teeth seen in mammals. Its skull was divided into distinct compartments, and it had large nasal cavities, suggesting a strong sense of smell, useful both for hunting and for locating carcasses. As for behavior, Ankylosaurus may have been a powerful predator, capable of crushing large prey with a single bite. But it could also have been a scavenger, using its strength to fight off other carnivores for access to fresh kills. With its enormous jaws and heavily muscled neck, it had everything it needed to smash bones and tear through flesh. Its body, however, was less refined. Its legs stuck out to the sides, more like a lizard than a modern mammal, giving it a wide, sprawling stance that made it slow and heavy. But speed wasn't part of its strategy. It relied on getting close enough to land a single, devastating bite. In a world where might often made right, Ankylosaurus lived by the rule, slow but crushing. And like many prehistoric giants, Ankylosaurus eventually faded out. As the Permian progressed, the climate changed, ecosystems shifted, and smaller, faster predators, like gorgonopsids, began to take over. Ankylosaurus, built for raw power and intimidation, couldn't adapt quickly enough and was left behind by evolution. Fossils of Ankylosaurus are mostly found in South Africa, in what was once a lush, swampy environment teeming with large herbivores. The massive skulls uncovered there continue to amaze paleontologists, not just for their size, but for the clues they hold about the transition from reptile-like ancestors to mammal-like predators. Today, Ankylosaurus stands as a symbol of an era before dinosaurs, when the world belonged to bulky, bony-headed brutes. It didn't rely on speed, agility, or cleverness, only on the fact that it was too big to ignore and too strong to challenge. In a world racing toward efficiency, Ankylosaurus chose to become a living sledgehammer, slow, loud, and impossible to overlook. These creatures were part of a group called synapsids, early relatives of mammals, and they show how diverse life was before dinosaurs ever appeared. Previously, their survival depended on adapting to dry landscapes, hunting techniques, and body features like sails, armor, or fangs. Previously, some of them developed unique body temperatures, breathing methods, and brain structures that would later evolve in mammals. At the end of the Permian period, Earth was a strange and brutal place. Across the vast, dry plains, bizarre creatures ruled the land. Scutosaurus lumbered like a living tank. Inostrancevia stalked prey with dagger-like fangs. Ankylosaurus walked around with a skull the size of a sledgehammer. And Gorgonopsids, quick and merciless, sat atop the food chain. This was a world where every evolutionary step came at a cost, and only the strongest, or the strangest, survived. Then, the Earth changed, in a way that no creature could endure. Roughly 252 million years ago, our planet experienced one of the most devastating events in its entire history. The end Permian extinction, also known as the Great Dying. This wasn't just another extinction event. It was a planetary reset. A mass biological collapse that reshaped life itself. The losses were almost unimaginable. More than 90% of all marine species disappeared. Over 70% of land-dwelling creatures vanished. Entire ecosystems were erased. If a sea scientist had been around back then, they might have said, the planet is undergoing total ecological shutdown. The trigger came from an unlikely place, Siberia, not because of cold, but because of heat. In a geologic region now called the Siberian Traps, massive volcanic eruptions began, and they didn't stop. For hundreds of thousands of years, possibly more than 1 million, supervolcanoes spewed lava and gas into the atmosphere non-stop. Carbon dioxide, CO2, sulfur dioxide, SO2, and other toxic gases flooded the skies. Earth, quite literally, developed a planetary fever. As CO2 levels rose, global temperatures soared, the oceans warmed and began to lose oxygen, deep waters became unlivable, marine invertebrates, coral reefs, primitive fish, and even plankton died out en masse. On land, forests withered and collapsed, leaving plant-eaters like Scutosaurus without food. And when the herbivores died, predators like Gorgonopsids followed. The food web didn't break, it shattered. But the worst was yet to come. Methane gases, trapped for millennia beneath the ocean floor, began to release, supercharging the greenhouse effect. A death loop began. Hotter air, less oxygen, fewer species, more carbon. Some studies even suggest the ozone layer was damaged, allowing harmful ultraviolet radiation to bombard the surface, killing plant sprouts, insect eggs, and young animals before they had a chance to grow. Imagine a world once filled with strange, vibrant creatures now reduced to sludge, microbes and silence, no fish, no lizards, no thunderous footsteps, just a dead calm, and maybe a few bacteria clinging to life in the mud. This extinction didn't happen overnight. It stretched out over hundreds of thousands, possibly millions of years, but in geologic time, it was still a blink of an eye. For the living creatures of the time, it was a drawn-out apocalypse. No asteroid, no sudden impact. Just a planet changing faster than life could follow. The world of the Permian ended not with fire or ice, but with heat, gas, and suffocation. The great armored giants like Scutosaurus, the blunt force predators like Ankylosaurus, the saber-toothed hunters like Gorgonopsid, gone, lost beneath layers of red rock and time, and yet the story didn't end there. Life, though battered and burned, refused to die completely. In the darkness that followed, a few survivors, small, adaptable, and unremarkable, hung on. A handful of insects, some tough little reptiles, and a small, resilient group of therapsids, creatures that many millions of years later would give rise to mammals. When Earth slowly began to heal, after nearly 10 million years of desolation, a new chapter began, the Triassic. A different world, a different cast. New forests, new skies, and, soon, new rulers, the dinosaurs. The end Permian extinction wasn't just the close of a chapter. It was a torn-out page that made room for everything that came next. Imagine standing in a world that has just survived an apocalypse. There are no more hunting calls, no rustling wind through dense forests. Scutosaurus is gone, no longer grazing silently. Gorgonopsids no longer stalk the shadows. It seems like everything is over, and yet, in that silence, something remarkable is happening. Life, fragile as it may be, has not given up. The end Permian extinction left the deepest scar in Earth's biological history. And yet, from that devastation, a few small, stubborn species began to rise again. They weren't large, they had no terrifying teeth, no thick armor. They survived thanks to one thing: adaptability. They could eat almost anything, live underground, withstand harsh climates, and reproduce just enough to keep going. Among them was a special group, synapsids, creatures with a single temporal opening in the skull, early signs of differentiated teeth, and jaws that chewed more efficiently than their reptilian cousins. Most of the famous synapsids, Stemenosuchus, Dimetrodon, and Ankylosaurus, were long gone. But a few smaller, less spectacular synapsids endured, hiding in burrows, clinging to life in isolated corners of the world. These survivors were the distant ancestors of mammals and, eventually, of us. In other words, without the Permian, or more precisely without the devastating collapse of the Permian ecosystem, dinosaurs might never have risen to power, and mammals might never have had their chance. The death of the Permian era opened space for life to reinvent itself. Everything that followed, dinosaurs, birds, mammals, humans, was only possible because of the ashes left behind. But the legacy of the Permian isn't only evolutionary, it's also a profound warning. The extinction wasn't caused by an asteroid or cosmic accident, it came from within Earth itself. A slow, suffocating cascade of volcanic eruptions, rising carbon dioxide, warming temperatures, acidifying oceans, collapsing food chains. It was the planet overheating, choking and unbalancing its own systems. Sound familiar? Today, we're seeing something eerily similar. Carbon dioxide levels climbing to record highs, oceans warming and losing oxygen, biodiversity disappearing at accelerating rates. The Permian doesn't feel like ancient history anymore. It feels like a cautionary tale coming back to life. And so, the creatures of that era, Gorgonopsids, Scutosaurus, even the massive Ankylosaurus, may be gone, but their story lives on through us. We are a product of the evolutionary journey they began. We carry in our bodies, our cells, our DNA, the echoes of creatures that once crawled across scorched Permian soil. The collapse of the Permian asks us a question. Is survival about strength, or about knowing how to rise after a fall? Maybe the answer lies with those unremarkable survivors, small, unnoticed but unstoppable, who went on to write the next chapter of life. Today, we may have supercomputers, space stations and genetic engineering, but we are still, in some strange and poetic way, descendants of creatures who once clung to life in silence 252 million years ago. Life is messy, imperfect, but it has one miraculous trait: it does not give up. And perhaps the greatest legacy the Permian left us is exactly that. Long before dinosaurs ruled the Earth, before the first footsteps of humankind, this planet belonged to a very different world, a world dominated by strange, massive creatures unlike anything alive today. It was the age of Dimetrodon with its sail-like spine, of Gorgonopsids with saber-sharp fangs, of Scutosaurus, armored like prehistoric knights, of Ankylosaurus, heavy as a walking boulder, and then all of them were gone, erased in an extinction so devastating it nearly ended life itself. But from that very ending, life began again. Today, when we look at fossils, we don't just see bones. We see stories written across hundreds of millions of years of evolution, survival, and the stubborn refusal to quit. Every creature from the Permian, hunter or prey, played a part in the long journey that eventually led to us. And now the question is no longer what happened, it's what will we do with that lesson? In our world today, we have science, technology, and the power to shape the future for better or worse, but at the heart of it, the same truth remains. Will we stop before it's too late? Because here's the thing, life always finds a way to go on, but there is no guarantee that we'll be part of it.